Hi and welcome to my new tutorial. The main idea of this tutorial is to talk about the clean architecture in Flutter applications. And we will go deeply to implement the many features in application which will depend on each others. And we will handle this process in a good manner. Before starting tutorial, I would recommend you to go to the given list if you are new beginners to Flutter or mobile development. So let's talk about our application. We have a simple application in which you are writing a query and application will search an album from the iTunes service and show your result as a list of albums. It's a one feature, and second feature is your user can remove or add this album to its local database. So we have two features here. What's the problem in these features and in our application? These two features, if we are divide them as independent features, they should not depend on each other directly. But in our UI, they are using in the same UI. So how can I solve it? How can we solve it? So main idea of this tutorial is to talk about it. But firstly, we will talk about other things in our application, which will be beneficial for you. First is Melos or Monorepo architecture, Melos package manager. If you don't know about it, you can read in Melos Invertex Dev. It's a documentation of Melos package manager and why we are using it. Our application depends on many packages which is written by us. For example, Google Book Service, iTunes Service, MovieDB, and so on. We will focus on iTunes Service in this tutorial. But we have an application which should depend on these packages, and all packages will depend in each other. Will depend or will not depend. It's on the case. How we can handle this process? Because if we don't know about Melos, we will go to project or each dependency, each package one by one, and we'll run the Flutter pub-get command. It's time-consuming process. That's why we are configuring Melos YAML project, and we define which of packages we have. And other things will be handled by Melos. We are just running Melos BS or its bootstrap. Melos bootstrap. And it will handle all pub-get process of our application, as you can see. Okay, and why it's called Monorepo? If we go our GitHub repository, you see that all of our applications are stored in the same repository. That's why it's called Monorepo architecture. And benefit sides of this implementation is that you will divide your services, your packages, your design system, or other things in the separated package, and you can reuse it in other applications if you have. Let's talk about the REST service of our application. It's an independent package we have written. So if you have experience with Flutter development, I'm sure that you have used HTTP or DO packages to make an HTTP request. So I assume that you have used DIO or HTTP client itself as a request base. So you have injected your DO or HTTP instance to data source or other layer and have a request. So in more cases, it's okay. It can be good for your architecture, for your application. But from the clean architecture side, it's about failure oriented, we can say like it. So why it's like that? For example, assume that you have used DIO or HTTP package, and in some cases, in some version, DIO package changed very deeply, deprecated more things, or HTTP package. In this case, if you have dependent on the HTTP or DIO package itself, your data source will be affected more. That's why we have created an abstract layer, an abstract class called REST client. It just gets a base URL and header parameters and make a request. But it's an abstract class. We just defined an abstract methods here. And we have the code body, which will be used in the implemented class. For example, if you use HTTP or DIO or retrofit, it doesn't mean which you use. We just extend the REST client and we inject our client instance to there, and we write our function implementations. For example, we have a send function here, and we handle the function or inside the function HTTP requests and results, errors, and etc. In DIO, it can be different, sure, but our class will be extend REST client. It's a main thing. So in our application, for example, in our UI, we are using iTunes service. The search process goes from the iTunes service. Here we have an album data source protocol. And by the way, we have written it like a clean architecture. We have a data layer and data source. And we have written a data source protocol. And as you can see, it returns album DTO. It's DTO, it is data transfer object, which parses from JSON to JSON, from map to map functions, or etc. And our implementation class, album data source import class, inject a REST client instance, not HTTP or DIO instance. It is REST client instance. So we have not dependent with HTTP or DIO directly. We have decoupled our data source and client itself. And that's why we can write our unit testings or other testings. We can mock our REST client easily. And we are not directly dependent to HTTP or DIO packages. And as we go, we show that we know that here we have entities. So in domain layer we have entities. It's the same thing with DTOs, but it just stores immutable data. Entities are just entities. It doesn't have any logic inside it, so we didn't parse anything here. It's just a data class. We can name it as a data class. And for UI, we just return entity. We have received an entity. So our album data source returns list of album DTO, but repository should return entity. For example, here we have album repository implementation. We have defined again a protocol for repository layer in domain layer, and we have implemented in data layer. So here we have injected album data source, not album data source implementation. We have injected abstract class. So we didn't directly depend on data source in repository. And here we request our query. For example, in this case, we request a list of album entities, and we get details of list. So how we will return album entity, because it returns DTO. So we have written an album mapper class. It can be anything, any implementation, doesn't matter how you write. I just export it as its independent class. You can write it in the implementation of the album repository as a function, maybe. Album mapper goes through the list of DTOs and exports them, maps them as album entity. That's it. Okay. And core exceptions in this folder, we just created some exceptions. For example, in our album case, it's album not found exception. Okay. Album not found exception will be through from the data layer. Look at here. We have checked if our response or albums is empty, is null, or album is empty. We threw album not found exception. Okay. We didn't handle any try catch in repository layer. We just get response, parse it, and return it. A repository doesn't relate it to the exception handling. Okay. It's our iTunes layer, iTunes service. So REST-client is our most underrated service. We can name it as underrated. And iTunes service depends on REST service. So next thing I want to talk about is database service layer. It's also an independent layer on its own. Okay, let's go to the code. As you can see here, we have a next database service. And next database service is dependent on a Drift package. It's a wrapper for SQLite. You can read more about its in its documentation. Drift simonbinder.io. Have a great tutorial about Drift, and I think it's easy to learn for developers who have an experience with SQLite or SQL. Okay, here we have just configured our build YAML with Drift Devs modular, because by default Drift generates all things in next database, and I think it's a bit confused. That's why I have configured it as a Drift Devs modular enable true. So it generates all things in its own folder. For example, tables on its own folder, or DAOs on its own folder, or database on its own. It's more clean, yeah? Okay, let's talk about a bit Drift package or its functionalities. Here we define a database, and this database can consist of many things. In our case, it's tables, data access objects, but you have rights, for example, views or queries and something else. Why we have defined migration here? Because by default, foreign case relationship is not enabled in SQLite. That's why we write a custom statement and we say to database that please enable foreign case. Okay, and it's version 1 because we have started it newly. Okay, and here's the name of the database. It will create a database in the specific folder for our application, in application folder. Okay, what about our tables? For example, if we go to user collection table, we define a table by extending a table and define our fields by its column type. Okay, I think it's simple. I don't want to go deeply about anything in Drift table, but I can show a bit confusing parts. For example, in our albums table, it depends on the user collections table, how we have defined it. Here we write a collection ID, and we say that it refers to user collections ID. So it's the foreign key to the user collections ID field. Okay, and when user collections ID field we have referenced is deleted, in this case all fields with this collection ID in album table will be deleted too. Okay, that's it. The most confusing part in the table side in our example, in our application, is that. Okay, and we can go to data access object too. It's a Drift feature. We can write a database accessor for our database. It's a wrapper. We can say it looks like a data source in our iTunes service example. Okay, and here we write our queries. Why we write album data access objects? Because our repository layer, which will depend on the album data object, shouldn't handle the queries by itself. So directly with the database, we should inject with the help of album deos, okay, or data objects. So as you can see, we have created album deos, books deos. For each table, we have created a new data access object field. And here we have some functions like search, get list, or delete, get, mark as listened, and something else. It's not main thing you should know about. Okay. Database layer consists of these examples, and next thing is go to the Notion file, future implementation. Okay, so we have iTunes service, we have Next Database service. Okay, so we needed repository, but in database service I don't want to write repository. Why I don't want to write that repository? Because this repository will handle only the local data. Okay, but repository can handle remote and local sources. But in that Next Database service, we just only handle local data source. So if we want to handle album data source like a remote, we should relate to iTunes service, but it's complicated because our Next Database service should depend on iTunes service or Google Books service or Next Movies DB service and etc. So that's why I don't write any repository for data source, local data source, or data access objects. Sorry for my pronunciation problem. So that's why I created a facets package which consists of the facet pattern for each entity. Okay, here we have defined, for example, album facet. Album facet, it extends from the generic typed facet, because not only albums, we have other types like podcasts, books, movies, all works as the same. That's why we have written an abstract class and implemented in the specific class. As you can see, when I extend or implement this class, I defined it works with album entity and albums companion. Albums entity is from iTunes service. Okay, so facet relates to and depends on the iTunes service package, and albums companion from the local database, Next Database service. It is used for insert, update events, or something else. It's generated by Drift package. It's not written by ourselves. Okay. So as you can see, we have depended on iAlbum repository from the iTunes service and albumsDAO. It's from the next database service, and all its functions which we want in the UI layer or in state management is defined here. Okay, so our block or other state management solutions will not depend on data access objects or repository directly. We will use a facade as an injection by the type album facade. Okay, so it's other level of the decoupling between state management and our data access objects, database layer or network layer, data layer. Okay, it's the same thing with the local database or remote repository. It has no the other things different from them. That's why I don't go deeply here. Okay, just we define functions from both of them and write an abstract layer for our state management. Okay, next one. Feature implementation. Okay, feature implementation, it's related to application itself, yeah? So we go to the application and first check the pubspec.yaml file, what we have here. So as you can see, REST service, iTunes service, but keep in mind that we didn't directly depend on these services. We just use it as an injection because we needed these service instances to inject them to the UI or state manager and use them. Okay, we should create its instance. Database service and facades. Okay, we didn't depend on the REST service. REST service is only used from the services like iTunes, Movies, or Google Books service. It's a pubspec.yaml dependencies structure. So next one. Okay, in application folder. Okay, first of all, I want to talk about features. We have album persistency feature and album search feature, as we defined in the starting part of our recording. It's a list search and it is a persisting, yeah? But how we will divide them? First of all, let's talk about, I didn't add here, dependency injection, global and feature based. So we have two types of dependencies. Okay, it's a global and scoped dependencies. Yeah, what's the difference between them? So assume that database or REST client or logger, for example, or crash lists, these are global dependencies because when application is started, all of these dependencies will need from the anywhere of the application. It's singleton classes, okay? But we didn't define them as a singleton because singleton design pattern is a anti-pattern. It's defined as an anti-pattern because it's not easy to test them. That's why we write a dependency injection mechanism. By the way, you can read more about it from the Sizzle starter. It's a repository written by the Lazabny. It has documentation. Some of the parts in the dependency injection is used from the Lazabny code base, okay? But we have improved it a bit. Let's talk about more deeply. So, global dependencies. We have a global folder. It's singleton dependencies we have defined here. So we define base class, or it doesn't matter base class or which class. Its context is more required. So we defined our all global dependencies, which needs to define as singleton. So in our case, it's a HTTP client and next database client, because no matter which feature we use, HTTP client or next database can be used. So we didn't scope them, okay? And dependency factory. And look at here first. We have factory abstract class and the async factory abstract class. And these are factory classes which just define factories to instantiate our containers. Async factory will instantiate with as a future, and next one as a synchronous. Sorry. So in our global dependencies factory, it's defined in factory type because there is no asynchronous process here. But in some cases, for example, if we have used shared preferences, for shared preferences, we will use async factory. Yep, because initialization process of this package is like in future implementation. Yeah, and we have defined in client next database here and returned it as a dependencies container. We defined here. I think it's a simple, yeah. And next one is, let's go from there, is composition root. Okay, composition root is dependency injection mechanism. We can name it as it. You can read more about it from the Lazebny article. Okay, from here, dependency injection in Flutter, you can read more about a composition root or something else. Okay, it's a commercial, that's why I didn't share all context in here. So composition root just accepts a config. What is a config itself? Config class defines, for example, API keys, base URLs, or some other configurations which needs by the application to start our application. Okay. In our case, it's a, for example, iTunes API URL, Google Books URL, Google Books API key, Movies DB API key. Okay, where we read them, they are defined in config JSON file. I didn't open it because we have a case here which is defined for our project. It is just defined as a JSON class. Okay, and we can read them with string from environment field, which is defined by the Flutter itself. So we send it to there because some of our dependencies, global dependencies, need it. So in our case, it's needed, but in some cases it can be needed. Okay. And here we create a logger, and logger, it's used by logging package from the pubdev. It's developed by Dart team. And we create a stopwatch from the clock package. It's also developed by the Dart team to compute how much time we consume to start our application dependencies. Here we create global dependencies by calling the create function of it, and then stop our stopwatch and make a result as a composition result class. It's simple class, just collects a dependencies container and return it from this function. It's a simple function. Okay, so let's run it. As you can see, it gives information about initialization global dependencies. Next, when it's completed, global dependencies initialized, and we have stopped our stopwatch, and we print the consume time. It's here. It's just a very little millisecond. Okay, you can make it as a elapsed in milliseconds to show more about milliseconds value, and it will show just 11. It's very little number. Okay, Okay, where we will use it, how we will inject it to the UI for all application. Okay, after composition root is defined, we go to the main, and here we call it, okay, we call it, as an example, we can show that we create a config class. It's a constant class. We can create many instances by them. We will just create one instance because it's a canonical object. It's const object, okay? And we get the composition result and send it to our next app. It's a main app class. And here we get a result as a constructor parameter and send it to the dependency scope. It is a simple dependency manager. It's a simple inherited object if you know about it in Flutter. So let's go deeply. Dependency scope. It just accepts dependencies as a dependency container. It's a dependency scope of context function when we need to read about the global dependencies, and that's it. It's for a debugging side. It's like a DevTools or something else. By this way, we ensure that our global functions, dependencies will be provided for all applications. We can read it from anywhere through the application with just context. Okay, we will show about it. We will see an example. Okay, it's a global dependencies. If you understand this implementation, features implementation will be the same thing. It's not any different. Okay, next one, features. The main part of our tutorial is features. Yeah, features layer. When we go to the album search page, it opens here. It starts from the first of all, please don't accept features like pages. Okay, if we have a simple page, for example, but we have, for example, in this case, search and persistence, it's not the same feature. It's independent features. First of all, we should define how we can divide features. You should divide them logically, not programmatically. You should define. You should divide them as, for example, business feature based. Okay, we can define it like it. And in our case, we provide two features for user. User can just search an album, okay, or user can just persist it. It's an independent features. User can search something and can't persist, for example. It's normal flows, okay. That's why we can divide them as an independent features. But both of them in the same place can be defined as a flow, okay. It's like a album search flow or album persistent flow. Okay, that's why please don't accept pages, screens as an independent feature. One screen is not one feature. Okay, that's why I have written an example like that. It's a simple page, but it has two features. So let's go deeply one by one to our features. And first of all, I want to start from the album persistency because it have a different thing here, album persistence API, which we'll touch in the upcoming session, okay? And first of all, look at the blog. It's a simple blog. We didn't have anything different from your implementations in your applications. Here we have an event which is used for when the user wants to save something to local or unsave it from the local database. For example, Okay, for example, add. Okay, it calls this event, and when we remove it, it calls album removing event. Yeah, it shows from the logging side. Okay, a state is a simple class. I didn't implement any difficult logic for our blocks. It's just for illustration purpose. That's why I kept it simple. And it's just saves recently added IDs. Why we saved them? This feature just persisting. Okay, we can. By the way, we can add the error message, for example, string message or something else here, because a single state. As you can see, we have two state writing mechanism in block architecture, in single class state and multi-class state. You can define here some other states and return them with your block. Okay, recently added IDs will save our search results in which we have added. Okay, when we search for something and add it to local database, it will be saved to recently added IDs. Okay, we return it to the UI, because UI should know about that, which one is added or which one is not added. Okay, it's a first point. Next one, look at the block more deeply. So here we first notice that album facade, which we have created before, it's from the facets package. We are not dependent on the repository or data access object. We just dependent on the album facade, but which type? Album facade. Okay, we are dependent on the abstract, not itself. So next one is a map. This stores two things. First part is the remote IDs, because when we search for albums, it returns some entities with his own IDs, which is defined in the global server, its own server. Next one is our local database. When we write it to the local database, I will save it with its local database ID. Okay, so this map will save recent IDs, which is persisted in the local database. When I save an album to the local, I just get an album. Okay, I persist it with the album facade using the album facade persist select item function. Here we have a collection ID, but it's no matter. You shouldn't know about it, because assume that we have many collections from the previous screen. Many collections we have previous screens. We tap one of them. It has own ID, and we save albums in the given ID. Okay, we defined for now statically, but it can be changed. It's now the main aspect of our records. Okay. Let's go. Okay. After persisting our album to the local database, we get an ID. Okay, it returns by the drift package from the SQL flight. If you know about SQL, when you write something to or insert something to the database, it returns an ID of it. Okay, and we get this ID and we save it to the map. Here we have a remote ID, and here we have a local ID, and returned it to the UI. For now, we didn't implement any error case UI, but you can define any independent state through or emit your error state to the UI and show it with with the help of toast or snack bar or something else. It's easy. If you know the context of this record, you can implement it by its own. Okay, in the same thing happened in album removing function. Again, we get an album and we get its local ID because we should remove it with the help of local ID. And we remove it with the help of local ID. We call the delete from the album facade. And after delete successfully completed, we call the remove from the local database, map, our map case, because UI should be updated. And we emit it to the database. And here we write a function, map remote IDs. We returns only the local IDs to the, we returns only the remote IDs to the database, to the UI. Because UI just know about remote IDs. Entities here are album entities, which has the ID field from the remote database, from the server. That's why we just threw the remote IDs to the UI as an set. So that's why we write a function which converts, which maps our map to the set using just case, because our case in our map is remote IDs. Okay, it is just album persisting block. Okay, let's go. As you can see, we didn't have any UI here. Okay, I forget to delete the view folder. We didn't have any view here, any UI here, any widget here. It's okay. We can have a functions. We can have a we can have a features which didn't have any UI. Okay, next one, album search. Album search is just a search from the remote repository, but here's a problem. Our album search items have add button, but this add process is processing by the album persistence feature. Okay, that's why we should depend on the album persistence. But how we can do it? Let's go deeply. So here again we have album search event which query some string from the API and send it to the block. It's a simple block state manager. And album search state, we have initial, success, and something else. Or here we have album not found, album search failure, and something else. Okay, so here we have some different things you can see. It's a selector class. We defined it to know that which item is selected or not selected. Okay, it just store the type, t-type, generic typed data, and boolean field like selected or not selected. Okay, so that's why we return this type of items from here. Selector is not defined in album search, album persistence. It's defined in the core. It's a global class. Okay. Okay, so how we will return it? Main thing is that for this reason we should know about feature API. It's called a feature API. When our one feature should depend on other feature, we write an protocol, we write an API from one feature and inject it to other feature. Okay, return there we have album persistence API. Okay, album persistence API. Why we need it? Because if we depend directly from the album persistence block, it's problematic. Because album persisting block is difficult for mocking, for unit testing, or for changing other state managements. That's why we write an abstract layer again, which will returns our IDs, which is persisted in the local database as a stream int, okay, as a stream. Here is a simple function. We inject the album persisting block here and returns it by awaiting for loops, okay. Just we yield a new state recently added IDs. It's a simple, but this stream, where this stream comes from, it's from album persisting block itself. It's implemented by block class, okay. It can be different in provider or in getx or something else. It's not same, but I want to share main logic with you, okay. So this abstract layer allow us to depend on other feature. Let's know about it. We defined album facade. Why we defined it? Because we search it from demo database, yeah. And album persistence API. You see, album persistence API. We didn't depend exactly from the album persisting block. We depend on the album persisting API. It's abstract class. Oops, sorry, it's abstract class. So after that, we defined here, we are listening from ID stream from this persistence API, not from block. We listen from the persistence API, okay. And we have some logics here. We can go deeply. For example, if we didn't get search success state, because in success state we have add events, and if it's not success, we returned it. We break here. And in another case, we get current search items and add them IDs to the recent IDs field we defined here, because recent IDs will change by the add or remove events, okay. And then filter our albums, because we should change them to true or false. It's added or removed. Filter for change just goes through the current search items. For example, if I write here pastor, it gets a 10 item here. It goes through them and check if the current items ID is in the recent IDs. It's selected, it's added. Otherwise, it's not added, okay. It's just for filtering function. And on album queried function, we again get a search request and parse them to the selector instance, because our album facade returns list of album entity, not list of selector entity. That's why we should convert it to selector type. That's why map to selector function goes through the albums and parse them, maps them to the selector class, okay. So most important layer of our application is the UI layer. How we will inject it to the UI, yeah. So let's go. It's more fancy point of the application. I like it. So I have just one page, album search page, okay. Album search page collects two feature in its own. Okay, first of all, we should define our dependencies. But these dependencies is scoped dependencies. Why scoped dependencies? Because when I close this page, our dependencies should be disposed, because we didn't need album persistence, because it's proceeds from this page, not from the outside, okay. That's why we have it dependencies on its own. For example, for our album search page, we have a container which defines album data source, album repository, album facade, okay. It can be more things, it can be other data source too. It depends on your page. And keep in mind that scopes for our scoped layers, for my opinion, it should be provided from the page, not from the each widget individually. You should define them, you should provide them above the page itself, because otherwise it will be difficult to handle. With read the context and define it again, provide it again, it will be difficult for handling. You can provide your instances, if it's scoped, above the page itself. Okay, here we have again the same things, again the dependencies container, and here we have a dependencies factory, but one thing here is different. A dependencies container we need, it's a global dependencies. Okay, we need here a global dependencies which will needed by the album data source, album repository, and etc. Config itself will return iTunes base URL to us. Okay, first we create a client and we read the iTunes base URL from the configuration, and we put our HTTP client from the global dependencies, and then we create the album data source, repository, data access object, facade, and all of them are provided to the UI. Okay, we can provide HTTP REST client too. It doesn't matter, it's okay. All of them will be disposed after this page is closed. Okay, how we will provide them to the UI again? So that's why we have written an album search scope, but you can implement it differently. Sure, you can implement it differently, not in my way, but I have created a provider scope. It defines two types of providing. First is new instance, second is previous instance. Okay, because you can provide some new instance which is not initialized previously, and you can provide an instance which is initialized previously, and you read it with the context and provide with this type. Okay, that's why our provider scope gets a T type, and it has a two constructor. First one is for the new widget, new initialization, new dependency. In this case, we get a child view and two functions. We will show and get more info about what these functions do. Okay, and second one is provider.value. In this case, we just get child and the value. Okay, so here we create and we can add it to here. Okay, and we create an instance and we check if it's new instance. We read the global dependencies and throw them to the dependency container builder and call this function, because this function will get new instances from your declaration and will provide it to the UI. And otherwise we just get the value you injected to this provider scope. Okay, and in the build layer, in the build function, we again check if we have a new instance. We call the widget builder with dependencies class, because in this case our UI will inject the dependencies to itself, because we can provide blocks or providers, other providers, or for example you are using other dependency injection. It's directly depends on your state management. Okay, and we created a provider value scope again. It's just inherit widget which provides a given T value to the UI. Okay, so we just provide our child and dependencies. Here we can remove it and we can replace them. Okay, it's good. And how we will use them? We just create an album search scope. We add here widget builder from the Flutter itself. Okay, we create a provider scope. In first function, dependency container builder, we create a dependencies which is needed from this feature, this page. So these are scoped features. Okay, these are scoped features. And again, you know that album search dependencies factory and its create function is called from the dependency container builder. Okay, it's just simple function. And next one, widget builder dependencies. But sorry, I forgot to say something. Here is the dependencies. It's a global dependencies. We read it from the dependency container builder function. We pass them to the album search dependencies factory because we need it. And widget builder with dependency. Here we have also dependencies, but it's an album search dependencies container. What's the difference? This function will be called before this function in the scope, and here we have dependencies which is provided by here. Why we need it? Because some dependencies from the source dependencies container will be injected to the block. Yeah, because we need facade, we need persistence API, we need something else. So we create a multi-block provider because we have two functions, two features here, album persisting and album search. We provide a block provider, album search, album persisting block, and from the dependencies we inject album facade. Okay, and album search block, from here we inject album facade, and we create album persistent implementation. We didn't create its instance from the injection level because it's just an API, it's just a language from between themselves. I think we didn't need to inject it from the container layer. It will be difficult for handling because we should pass a block to here. Okay, and here we read a context with album persistent block we provide here and pass them to the album persisting API implementation. Okay, here is it. And at the end we create a builder, and here we have a builder function. Because why we write it? Because context will be changed from the block provider. Otherwise we cannot read a context. Okay, that's why I add a builder here. Okay, and if we need to add a child to the provider from other packages like Flutter block need a child parameter, we pass this child to this function, as you can see. So you can use this child from this function, this field, to the multi-block provider. Okay. Yeah, scope is something like that, but how we will use it? Let's go to the album search page. In album search page, firstly, we define our search scope, okay? Search scope is just a widget. We can use it anywhere in UI. We provide it above our function, above our page. And then we defined our UI code. As you can see, it's simple code. We have a complicated logic here. We add, remove, and search, but we have a simple UI. Look at that deeply. We defined here album search block because it's just updates the UI according to search result. And here we use album search view. It's a simple view. We can check from there. It reads a block builder and change itself according to it. Okay, you can remove it from there too. From there too, because this layer will be replaced by there, so we can change it from there. I think it's not to define it many times. Let's check it. It's working or not. As you can see, it's again working because we are updating it in the album search view where we check the states and build the list according to our success states. Okay, and we have a different thing here. We have tricky point here. In album item, we accept album prefix builder because this add button will be handled by other logic, okay? It's not inside this album item layer, because this album item in the album source layer, but its persistent state or persistence function, it's not called from the persistence album source layer. It's called from the album persistence. That's why we have created a simple function, very simple callback, which is accept the album here and build a prefix. And we send it from the album source view here. Okay, we build here and it will call here. So you can see more about here. Wait a bit. We call it if prefix builder is not null. We give it some space and call a prefix builder. Okay. And in album search page, we created an album prefix builder. Here we created an elevated button. Okay. We have implemented the persistence logic call here. Why? Because if we call it inside the feature, album search feature, it depends on the album persisting block directly. So in this case, our search block, album search feature is dependent on the album persistencies with context. Okay, that's why we write a simple callback here to call it from outside. It's in the page layer, not in the feature itself. Okay, so we call it and check if album is selected again, because we wrap it with selector type and it returns the selector album entity. If it is selected, what we should do, we should remove it. We have written it album selected. Okay, it's good. If it's selected, we should remove it. Album removing required. If otherwise, if it's not selected, it's not added, in this case we should save it. Yeah, just a simple function. And here we check if album is selected, it's text in button replaced with removed text, otherwise it's add. So as you know, here we check and we can handle more field here, but look at, yeah, we save it and we go other places and we edit and we come back. You can see it saves the previous IDs and it's working as expected. So I hope that you got the main idea how we can implement clean architecture, how can we divide our features, and how can we join them, how can we decouple them with a good way. Okay, that's why please keep in mind that this tutorial is open to your feedbacks. It can be a difficult solution or it can be false solution, or if you can have any other alternatives to this way, I'm open to your feedback and we can talk about it. I hope that this tutorial is helpful for you, and if you enjoy about it, please share my tutorial with others. It doesn't mean you should share it with only Flutter developers. It can be shared in other mobile developers too, because it's one of the most I think one of the most important topics in mobile or other development sites. Okay, thank you for watching my tutorial. See you soon.